Welcome to this edition of Inscribed Ankles. This is 10-4 in your book, and today should be Thursday. So let me tell you a little bit about inscribed angles. So it's kind of what it sounds like. Inscribed, it's inside the circle. Be very careful with inscribed angles, because if you remember on a previous lesson we learned about central angles, and remember central angles come from the center. Inscribed, and remember central angles come from the center, and so whatever that angle measurement was, that minor arc was also congruent to that, right? So here we learn about inscribed angles, so be careful not to confuse an inscribed angle with a central angle. Inscribed angle has a vertex on the circle. Inscribed angle has a vertex on the circle, and sides that contain chords. It's so weird right now on this tripod. Yeah, my hand right now, who cares? So it has a vertex on a circle, and sides that contain chords of the circle. So if you look here, this inscribed angle, the vertex is on the circle. It's not in the center, it's on the circle, and then it's made up of two chords, chord EF and chord DB. Everybody see that? I mean DE. An intercepted arc has endpoints on the sides Intercepted arc has endpoints on the sides of an inscribed angle. And lies in the interior. Okay, I'm just getting lazy with my handwriting. I'm sorry. I'm tired. But I can sleep on the plane. Has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. Sorry, I'm just snorting my nose in the thing. It's gross. I apologize. Everybody got it? So what is intercepted arc? So we know it's central angles, and I kind of sketch one over here on the side. We had an angle that came from the center, right? And so this arc right here was called a minor arc, right? So here on the inscribed angle, the intercepted arc would be the arc that's on there. We can't call it minor because it's not coming from the center. So the arc on the inscribed angle would be called an intercepted arc. Everybody got that? Questions? Okay, so here are three circles. I'm sure Vishnu's saying, it's not a circle, it's an oval. Yeah, whatever. These are three versions of circles. And so, so the first type of intercepted arc, let's assume that was on there, can have an arc to where it's the center P is on the side of the inscribed angle. Is on a side. Another way you can have an intercepted arc is where the center is inside of an inscribed angle, and then of course you can have one where it's on the exterior. Everybody got? So I just realized that my thing was paused. I don't know when I paused it, so let me back it up a little bit. Sorry, and sorry if I already said this, so I'll repeat it. The theorem, I'm not sure if y'all heard it already. If you did, then fast forward, because I don't know when I recorded the last part. The theorem was, if an angle is inscribed in a circle, then the measure of the angle is equal to half of the measure of the intercepted arc. So if an angle is inscribed in a circle, then the measure is equal to half of the intercepted arc. Here in this one I talked about, and I'm just repeating in case it didn't record that part, so sorry if you hear it again. If we're trying to find angle 1, the measure angle 1 is going to equal arc AB divided by 2. So whatever the arc is, half of that. And you can write it as arc AB over 2, or measure angle 1 equals half arc AB. Everybody got it? And if you're going backwards and finding the arc, then the arc will be equal to 2 times the measure angle 1, because we know when we get rid of fractions, we multiply by both sides by the common denominator, so that's why it's 2 times angle 1. And that's that one. I already did this example. I think it wasn't recording while I did it, so I kind of go back over it. So in the first one, look at the orange. I already did the orange. So we're looking for angle RST, and its intercepted arc was RT. And so since RT was 120, the theorem tells us that we have to take half of the angle measurement. So we do half of 120, and so 120 divided by 2 is 60. And so that's how we got 60. Everybody got it? And so now we're on the next one, which I realized it was on pause on, and so that's in red. So we're looking for arc SU, which is the intercepted arc that's in between SRU. So when we look at this SRU, I just colored over it. I think that says 40. So we know that angle SRU is equal to arc SU divided by 2, right? We know angle RU is 40 degrees. And so if we want to find arc SU over 2, we double it, multiply both sides by 2, so that cancels out. And so arc SU is equal to 80 degrees. Everybody got that? All right. The next theorem. There we go. Says if two inscribed angles, and I'm sorry, I'm tired of writing. So just listen. If two inscribed angles of a circle intercept the same arc, if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So looking at this picture right here will really help you understand what exactly I'm talking about. So I'm going to color it in using my little kid's crayon. So here's the first one, ABD. So there's an inscribed angle, right? And if you notice, the arc that's connected at the bottom of that is D, AD. Everybody see that? Then we have another inscribed angle right here, ACD, and it also shares that same intercepted arc. So does everybody see that? We have two different inscribed angles, this one in orange, this one in red, and they both intercept the same arc AD. Everybody got it? So then the theorem tells us that those two angles are what? Congruent. So B is congruent to C. Got it? So you could say angle B and angle C, both of them intercept arc AD. Everybody got it? So then it means angle B is congruent to angle C. Oh, you didn't see nothing I wrote, huh? There you go. Questions? All right, let's go to the next part. Let's work out some problems. Yay, problems. I know you're so excited. All right, find the measure of angle T. So if we look, let's get my handy dandy notebook. No, I'm joking. This arc right here, I mean inscribed angle, STV has an intercepted arc of SV. Everybody see that? And then SUV also has the same intercepted arc, so they share the same arc. So what does that mean about the two angles? You're right, they're congruent. So I'm putting arc marks around them. So to solve this, we're just going to set them equal to each other. So we have 3x minus 5 is equal to 2x plus 15. Subtract 2x on both sides. X minus 5 equals 15. Add 5 to both sides. X equals 20. Is that all it wants us to find? Nope, it wants us to find a measure angle T. T is equal to 3x minus 5. So plug it back in. 3 times 20 is 60 minus 5. So that's going to be equal to 55 degrees. Everybody got that? Alright. Whew. I'm tired. It's a lot of teaching. We still got 2 more theorems to go to. I mean, not got. We still have. This one should be pretty easy. If you look at it, you should notice, bam, it's a semicircle. So here, this intercepted arc is on a semicircle. So you should kind of use context clues and know what I'm about to say. Yeah, you're right. An inscribed angle of a triangle intercepts a diameter or a semicircle. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle's a right angle. So an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So if you notice, we have arc FJH. That's a semicircle. Everybody got that? FJH is a semicircle. So that tells us then angle G is going to be equal to 90 degrees. Everybody got that? And so if angle G is equal to 90 degrees, then that means FJH is a semicircle and FH is a diameter. So we can conclude FH is a diameter. Got it? All right. Let's look at example 3. Uh-oh, I gotta speed it up. Oh my gosh, I only got 3 minutes left to tape. Okay, so find the measure of angle F. If we look at angle F, it's on the, so we have FGH, which is, I lost my train of thought because I'm trying to rush, is a right triangle because it's inscribed on a semicircle. So it wants us to find the measure of angle F. So we're given 90 degrees, we don't know none of those, so we have to use triangle sum. So we're going to add it all up. 4x plus 2 plus 9x minus 3 plus 90 is all equal to 180. Combine our like terms and we end up with 13x minus 1. No. Yeah, it's minus 1 plus 90. I forgot to add that one in. And so that's 89. A positive 89. 90 plus 2 minus 3. Yep. It's equal to 180. Subtract 89 on both sides. 13x equals 91. Divide by 13. X equals 7. Everybody got that? What does the problem want us to find? Measure angle F. So it's equal to 4 times 7 plus, is that a 2? I can't even read. 2, so that's 28 plus 2, so your answer should be 30. Everybody got that? Okay, I'm kind of going to zip through this last part because I only have 2 more minutes of tape. 1 minute left of taping time, so you'll probably have to go to the book to get the rest. The theorem says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So L and N are supplementary, they equal 180. K and M are supplementary and they equal 180. Everybody got it? All right, gonna try to zip through this last one. It says a necklace charm shown uses a quadrilateral inscribed in a circle. Find A and B. If we look at this, we see the angle C is equal to 90 degrees. So that means this is also, A is also equal to 90 degrees because they are opposites. So then B, we don't know what B and D are, but we know that those two added together are going to equal a total of 180. So we would do 2x minus 30 plus that unknown x, and we know it's equal to 180 degrees. Solve it. That's going to be 3x minus 30 equals 180. Add 30 to both sides. That cancels out. 3x is equal to 210. Divide by 3. X equals 70. The question asks us to find the measured angle B. So we got to plug it back in. 2 times 70 gets your answer, get 110. Oh, I still had time. So yeah, 2 times 70 is 140. Minus 30 is going to be equal to 110. Sorry, I was trying to rush it. It says I have like 10 seconds, but 10 seconds is more than what I think it is. All right, thank you. Do your homework. Pause if you need to go back.